Good morning, Algebra 2 students. Today we're just going to have a work day working through operations with functions and inverses. I'm going to give you a couple videos here that you can use as a guide and then just complete the assignment that's in your digital day folder. First problem here, we are to given f of x and g of x two functions, and we're asked to add them, multiply them, subtract them, and divide them. So first of all, to add them, so this is f plus g of x, we're simply going to combine like terms. There's nothing similar to the x squared, so it would be 2x squared. We are combining the negative 3x and the positive 3x. Those would cancel, and then the 5 and the negative 4 would be plus 1. So when we add, we just combine like terms. Subtraction. The second problem here, we're going to add the opposite. So we're going to take f of x, which is 2x squared minus 3x plus 5. Excuse my stylus there. And then we're going to subtract 3x minus 4. To subtract, we're going to add the opposite. So add, change the sign on these. And then combine like terms again. So I'd have 2x squared. I have minus 3x and minus 3x, which would be a minus 6x. I have 5 and positive 4, which would be a positive 9. Multiplication. So now I'm going to take 2x squared minus 3x plus 5. And I'm going to multiply by 3x minus 4. So to do this, I'm going to distribute. I'll have 6x cubed, a negative 8x squared, a negative 9x squared, a positive 12x, negative times a negative. Distribute my 5, 15x, and negative 20. Then combine like terms, and your final answer would be 6x cubed minus 17x squared plus 27x minus 20. And then the fourth one, to divide, we're taking f divided by g of x, so I'm taking 2x squared minus 3x plus 5, and I'm dividing by 3x minus 4. In this case, there is no way that 3x minus 4 is a factor of the top quadratic. Therefore, there's nothing I can do to simplify this. I should say that x cannot equal positive 4/3, because that makes the bottom equal 0, therefore making it all undefined. Number 2, we are finding composition. You see the open dot there? So g of h of x, which is an open dot, can also be written like this, means we're going to put h of x into g, the h of x function into the g function. So it would be 2 times negative 3x plus 2 plus the 3. Distribute, so I'd have a negative 6x plus 4 plus 3, which would be a negative 6x plus 7. Then doing it the other way, so h of g of x, which also can be written like this, means we're going to put g of x into h of x. So it'd be negative 3 times 2x plus 3 plus 2. Distribute, so it'd be a negative 6x minus 9 plus 2. So a negative 6x minus 7. And then last problem, doing g of h of negative 3. You're going to do the inside parentheses first. So we're going to do h of negative 3. I'm going to put negative 3 in for h. Negative 3 times the negative 3 is 9, plus 2 is 11. So now I'm going to do g of 11. Putting 11 in for g would be 2 times 11 plus 3, which would be 25. Just double checking that, we did find the rule for g of h of x, which is right here. And if I would just put negative 3 in there directly, I would get also a positive 25. So it works, and it is checked out. The last question here, find the inverse of a relation. Remember, a relation is a set of points. And to find the inverse of something, we simply switch the x and y. So those points would be negative 5, negative 2, negative 3, negative 1, negative 1, 1, and 1, 3. That's the first part of the video. There will be another video for the back part of the formative assessment.